So in this section, we are going to discuss what is the behavior of spanning tree into the VPC. So as you can see on the screen, the BPDUs in a VPC environment are controlled by the primary device only. So it means that the primary device is going to generate the BPDUs and it is going to send the BPDUs on all the designated ports. So in case of VPC, the secondary device is not going to generate any BPDUs. Okay. So for example, in our case, if you look at this picture here, so we do have the primary device and the secondary device. So this is the VPC, so VPC 10. So our primary device is this one, right? So only the primary device is going to send the BPDUs to the downstream device. Let's say this is switch 1. Okay, so it is only the primary device is going to send the BPDUs, and the switch one is going to send the BPDUs to primary or secondary. It can also send the BPDU to secondary, right? Because from switch one we do have the port channel. So based upon the algorithm, it can send the BPDU here. Okay, but in that case, what secondary device is going to do, that it is going to send the BPDU over the peer link, because this is the secondary device and this is the default behavior. It is not going to process it, and it is not going to send any BPDU on the designated port. So in this scenario, we do have only one designated port with the primary device and one designated port with the secondary device, right? So only the primary is going to send the BPDU to the downstream device. And if the secondary device gets any BPDU from the downstream device, it is going to send this over the peer link to the primary device, and then primary device is going to send the particular BPDU to the downstream device. So this is the default behavior of spanning tree into the VPC environment. But let's say if there is one device which is connected here on the secondary device, which is not a part of VPC. Let's say this is switch 2. Okay, it is not a part of VPC. So in that case, secondary device for sure is going to send the BPDU. So just to summarize it quickly, so in a VPC environment, only the primary device is going to send the BPDUs on all the designated ports. Okay, and just in case the secondary device receives any BPDU from the downstream device, it is going to send that particular BPDU to the primary device. Okay, so now let's see it with a practical now. Okay, so we will use our same topology that we have been using in this series. So we do have N7K1 and N7K2, right? And N7K1 and N7K2 is having two VPCs, VPC2 and VPC3. So VPC2 is with N5K1 and VPC3 is with the N5K2. On N5K1, we do have the server one, which is having the IP address 20.1.1.100. And on N5K2, we have connected server 2 having the IP 20.1.1.1. So now let's see how the spanning tree behaves in a VPC environment. So if I go to N7K1, for example, and if I check some VLANs for, let's say, show VLAN brief, and just for the reference, so this port at N5K1, which is going to E0 or the server 1, so this port E1 by 7, it is on VLAN 10, and likewise on N5K2 port E1 slash 8, it is also in VLAN 10. So both these servers 1 and 2, they are in the same subnet. So we can check the connectivity here. If I go to server 2, and the IP of server 1 is 20.1.1.100. So we can see that we do have the connectivity, right? So if I go to switch 1 or N7K1, if I do a show VPC role, so N7K1 is the secondary, and that we already discussed why this is secondary, right, in our previous videos. And if I go to N7K2, just let's quickly check show VPC role. So this is the primary device. So now if I do a show spanning tree VLAN 10, let's say, okay. So for spanning tree VLAN 10, so for VLAN 10, the root bridges, you can see here that this bridge is the root. If I go to N7K1 show spanning tree VLAN 10, right? So N7K2 is the root bridge, right? If I do a show run VPC, so we do have interface port channel 1, which is the peer link, and we do have two VPCs, right? And N7K2 is the root bridge now, right? For other VLANs also, if I do a show spanning tree VLAN 20, you can see here that this bridge is the root. And what is its MAC address that it is using? It is using the 50340009, which is the same that we discussed as it is the local system MAC, right? If I do a show VPC role, so this 50340009, this is the local system MAC, and we also discussed that this local system MAC is derived from the VDC. If I do a show VDC, it is the same MAC. Okay, if I go to N5K1, let's say, and if I do a show spanning tree VLAN 10, we can see here, right, 50340009, and 009 is, you can see here that 009 is uh, N7K2, right? So what we discussed that only the primary device in the VPC domain is going to send the BPDUs, and it is irrespective of the uh, root bridge. It can be possible that your N7K1 is the root bridge, okay, but your N7K2 is the primary device. It doesn't matter who is the root bridge. So in a VPC domain, the only criteria that who is going to control the BPDU is the role of the VPC peer. So if for in our case, so N7K2 is the VPC primary device, right? So it is going to control the BPDUs. For example, if I do a show spanning tree, let's say interface port channel 2 detail. So you can see here the BPDUs sent. If I again run this command, so you can see that BPDUs are increasing here because this is the primary device, so it is sending the BPDUs. But if you go to N7K1 and if you run the same command, show spanning tree interface port channel 2, for example, sorry, let's say detail. Now you can see here, because this is the secondary device, and as we discussed in a VPC, the secondary device is not going to send any BPDU to the downstream device. So now that is why you can see here that the BPDU sent on this particular interface is 0. Okay, so this proves that only the primary device control the BPDUs in a spanning tree environment. Now let's say we go to switch 1. So now what is the drawback here in this type of topology is that, let's say our VPC primary device goes down. Okay, so if you go here at N7K, and if you do a show spanning tree VLAN 10, for example, because our both of our server are in VLAN 10, right? So server 1 and server 2. So and the N7K1 is the root bridge, right? And also it is the primary device. Sorry, not N7K1, it's N7K2. Show spanning tree VLAN 10. So N7K2 is the root bridge, and also it is the VPC primary. So just in case our root bridge goes down, let's see what happened. So if I go to switch or the server 2, and if we do a continue ping, let's say repeat, and let's say I go to the root bridge. So N7K2 is the root bridge, right? If I do a copy run start, and let's say I reload this device, okay, And if I go to, for example, let's say I go to here, so you can see here that for the VLAN 10, the root port for the N5K1 is the port channel 2, right? And we do have a couple of ports in the port channel 2. Show port channel summary. So we have four ports. Two ports are going to N7K1 and two ports are going to N7K2. So now if I go to N7K2 and if I do a reload, because this is our root bridge, right? So I reloaded my root bridge. Okay. Now if I go to N7K1 and if I do a show VPC, it will find eventually that the root bridge is down. Okay. You can see here peer is not. So eventually it will take over the role of primary, right? And if you check here, show spanning tree in VLAN 10, you can see here now the port state is changed, right? Earlier the port state was because the port channel 2 was the root port, right? But if you check here, show port channel summary, now your, because your two ports are still up, right, which is connected to the N7K1, but it is showing that it is a designated port. Why it is showing that it is a designated port? Because now the spanning tree is reconverging. Okay, because your spanning tree finds out that there is a change in the topology, that is why it is now reconverging. Okay, if you go here, then it will take over the role of the primary device eventually. Okay, so why it is happening is that if I go to switch 3, or let's say go to the server, so in the this is because this is EUNG, you may not get the expected result here. You can see here that you can see some drop packets, right? In the real devices, if your root bridge goes down, then you will experience around a 3 second of cut, or 3 second of outage. Okay, so if you now go to the N5K1, you will see that again it is portional to is the root port, because your RSTP or your rapid spanning tree is converges. Okay, so you can say that in a, when your root bridge goes down, you are going to experience around a 3 second of disruption. Okay, why this disruption is happening is because now you can see there that earlier the root ID was 00B, which was the root ID of the N7K2, right, which was the root bridge. But now our root bridge is down. Now N7K1 is the primary device. If I go here, show VPC role, now you can see here that N7K1 is the operational primary, right? And the primary device is going to process the BPDU, right? Now if you check here, show spanning tree interface port channel 2 detail, now you can see that it starts sending the BPDUs, because now it is the primary device, right? And this is the default behavior. And now the problem with this design is that you will experience 3 seconds of disturbance in your network, and when the root bridge comes up again, you are going to see the 3 seconds of disturbance. Why? Because once your root bridge comes back, it is going to announce again its bridge ID, which will be better than your N7K1, right? Then again the downstream devices are going to find out that there is a change in the topology, and again you are going to see a 3 second of disturbance. So in this particular scenario, we are going to experience around a 6 second of disturbance in our network. Okay, just because the downstream devices are they are getting a different bridge ID, right? Because earlier they were getting the because the, see, the priority on both side was the default priority, right? So but the MAC address is different, right? Because the MAC address in our case, uh, when the root bridge went down, it is 000A, which is the MAC address of N7K1. Earlier the root bridge ID was having the MAC address of 0009, which was the MAC address of N7K2. So this is how the spanning tree behaves in the VPC environment. So you are going to experience around 6 seconds of disturbance because of your reconvergence of your network. Okay. So in our next section, we are going to see what is the solution of this and how we can mitigate this problem of reconvergence of the spanning tree.